So for this example, now we're going to look for a blind SQL injection. So in this case, we're going to click read more. We're going to give it a single comma, nothing comes back. This one's a little bit tricky because we're going to have to rely on a little bit of a deeper understanding of this application. So let's go back to our examples homepage. We right click on the source. We're going to look for more places where there are different parameters. So in this case, we have article ID equals 1. That's where we had our previous SQL injection, and that's how we load the articles that are within this database. But at the bottom, there's also this function that says, hey, you can actually get article counts within the database. So if we put in the month that we want, so in this case, we're going to look for December 2020. That's going to say, hey, there are 0 articles in there. Where we know in May there were 2 articles, so we're going to switch this December for May, and of course it's going to come back and say, hey, May had 2 articles, and we can confirm that by going to the web page and seeing 1 and 2 articles that were published within the month of May. So now we want to check and see if this is vulnerable to a SQL injection. So the first thing we do is we give it the usual apostrophe or a single quote. It comes back and says, hey, nothing there. Give it another one right here. Okay, it's not really doing much. We're still not sure if there is a vulnerability here, but we're going to keep playing with it. So what if we added one at the end? We have to think about MySQL injections as you are ending the previous query and you're starting your own. So what if I do 2 of them? So I close the previous one. There's a dangling one at the end. I want to reclose it. Still nothing. What if we do 1 and we comment out the rest? Still nothing works. Again, with MySQL injection, it's very, very weird. You have to spend some time to see how the application reacts to whatever you're giving it. So looking at this SQL injection here, the only thing we can rely on is whatever value comes back from the database for the number of article counts within this month. So if we give it something invalid, it's going to come back and say 0 because it doesn't understand why May 2020 apostrophe means. So we want to make sure that we play with this query until we understand how it's getting executed. So in this case, it's doing some sort of a select and it's saying, hey, do this thing where the month equals to May of 2020. And then again, if you're having problems with the statements, just go ahead and look at the slides again, where we looked at what it looks like when you give it an ID or some value here. Where does that go? In this case, at this point, we're just playing a guessing game. And the only way to verify it is by actually giving it a math expression. So again, we don't know if we're doing this right or not. We know that there are some errors and some weird behaviors happening when we give it a single quote. But now we have to figure out a way to get a true statement in there, get this count to go back up to 2, because that's the only way we know there is actual vulnerabilities, and that's what the actual correct query would look like. The correct query would give us 2, which is the number of articles in May 2020. So what happens if we start putting the single quotes in different areas? Again, I don't know how this backend works. I want to break it apart. If I put one there, now what we're doing here is we're saying, hey, apostrophe right here. So I'm gonna convert this back. There's a space there, that's a space, and that's an apostrophe. So what's happening with our query here is, again, there is the value, whatever we put for May 2020 is being put into single quotes like this. So if we were to close it out with a single one, so if we put one here, this is the expression that's being ran in the backend. If I add a single quote here, we still have this remaining 1, right? Because in the backend it's hard coded, it's always going to have it at the end, so we have to somehow close it out. So what we can do here is we're going to give it a math expression. We already know that this works, and we're going to say, hey, I already know that it's going to add an apostrophe to the end of my query no matter what. I can try commenting it out. That may give me the right answer. But what we can also do is we can just simply put a single quote somewhere in there of our own, where, excuse me, let's do this again. We're going to put our own single quote to make sure that, hey, I want you to use the leftover apostrophe from the previous query by closing my statement. So we're saying, hey, I want you to evaluate this. There's already a hard-coded one in there that we don't see. And then I also want you to do and 1 equals to 1 and give me some data. We can also verify that this actually works by giving it an invalid math equation. So if we do 1 equals to 2, it comes back again with a 2. The SQL injection is kind of working, but maybe our apostrophe isn't put into the right place. So let's go back. and we're going to keep it as 1 equals to 2 because we want to get an invalid query, but we're going to move our apostrophe over to after the equal sign. Now you're seeing that the application is coming back with a count 0 because maybe the expression that we give it the expression we've given it for 1 equal 2 is invalid. But if we give it 1 equals to 1 and it comes back with 2, so that means it's evaluating it. Our math expression 1 equals to 1 is true, then that means we have a proper SQL injection. Anytime you're looking for a SQL injection, you have to account for the number of characters that may be left over because of the hard-coded query that's being ran by the application. So again, because we don't see any errors, we don't know where we're putting our expression, we're always playing a guessing game, but we have to understand how a SQL query looks like and how we should close it, or how we play around the leftover characters that may be there because we're injecting our own expression. So now that we have a working payload, again, let me replace these. So we have an apostrophe there, we have a space there, we have a space there, and an apostrophe there. So this is the query that we have, and we've proven it that it works. We're gonna give it an invalid one. Comes back at 0. Cool. Now it works. There is something here. Now this is the fun part. Here, a lot of people rely on tools. It's great if you know how to use these tools, if you understand how they work, great. That's awesome to use tools. But for the sake of this course, I'm going to show how we can extract data by actually using some techniques with SQL's built-in functions to kind of get the MySQL version. You can also use similar approaches to this one to extract data. I'll make sure I can link some stuff into the resources section of this chapter to make sure you have access to additional ways of extracting data when it comes down to a SQL injection. But for this case, what we're going to do is we're going to inject ourselves in the middle of these two queries. So I'm going to actually open up a notepad and copy this in, so we can kind of evaluate what does this actually look like, what is this query that we're running every time, and try and make some sense out of it. So as we talked about during our slides, the AND expression here, the keyword AND, what it's going to say is, hey, I want you to, whatever query you were running before it, I also want you to do this. So AND means, hey, also run this next query and the next query after it. What we're going to do is we're going to inject ourselves right here. We're going to do another and we're going to write a query where it tells us what is the version of MySQL based on our brute force, or us guessing the version. And this is something that I covered in the slides. We're going to use substring, and what substring does, it looks at the value of a particular string and it tells you what the first value is, second value is, or the third one is. @version is actually built into MySQL. It gives us the version of the SQL database that we're using, and this is again from MySQL. There are different functions and different ways of doing this for other database types. And we're going to look for the first position at 1. Again, this is, as I said in the slides, this is the starting position, and this is the position where you want to pull the data from. So we're going to set this to 5, and we're going to say, hey, is version of this MySQL backend a version 5? So we're going to copy this in. And that comes back as 2. We can also verify it by changing it to 4, or we can change it to 1, we know it's invalid, and that comes back as 0. So what's happening here in this case is the MySQL backend is running this function, and it's coming back as 5 point something something, and the substring is looking at the first value of that version and saying, hey, is this query true? Is it starting with a 5? And if it is starting with a 5, then show that nothing is wrong. But when we do 1, because it starts with a 5, it's going to say, no, that's not true. It's going to give back a 0 because there's some sort of error there, but we can't figure out what it is just yet. You can do this a number of different ways. Again, with bug bounties, you want to just show proof of exploitability. You can also show impact by accessing extra data, depending on the program you're hacking on. But in a lot of cases, showing this is good enough to kind of show that there is a SQL injection there is impact, you were actually able to extract data, and so on. Again, there are other ways you can extract other data. You can extract table names, column names, usernames, and so on. Most people either do this manually by writing really long queries, or you can actually do this using tools like SQL Map, which we're going to look at in just a sec.